Hello students, numerical on shift of interference pattern. Now, what is this pattern? What is the shift? What is concept? Here is going to be the answers for all. Now, concept of shift is nothing but the central bright band shifts by a position. Now, why does this shifts? Is because a refracting material is brought into the path of the midway. So, students, you can see there are two slits here and it is creating an interference pattern just as shown in the figure. But this is in absence of the refracting material. Now, if I introduce a refracting material, let us say a prism of thickness T and refractive index mu in front of this slit S1, how would be my rays traveling? The rays would be traveling like this and the pattern would be shown as it is seen above. Now, the CBB previously was beneath, but now it has shifted upwards. So the distance between the new position and the old position is nothing but x, and this x is nothing but the shift we are talking about. This was the case when there was only one refracting material, and this shift x is nothing but given by the formula, that is x is equal to, or x naught is equal to d by d mu minus 1 times of t. X and x naught are one and the same thing, students. Let's move to the next slide where you would be seeing two refracting materials are there. So this is in absence of both these refracting materials, the pattern is pretty simple. But when two slabs are introduced of same thickness but different refractive index, here mu1 is greater than mu2, my pattern shifts somewhat like this. You can see there is again the shift has moved upwards. The distance between them is nothing but, you can say, x or x naught, and it would be now given by the formula that x naught is nothing but capital D upon small d mu1 minus mu2 times of t, students. So this is a formula that should be learned before solving any numerical on shift. And how should be the approach of numerical? You should always equate this x naught with x, because x and x naught would be always same. So your first condition would be equating x and x naught, and you would be getting the values of desired unknowns. So let's see the first question for this particular concept. So the question is like, in Young's double slit experiment, on using a monochromatic light, the fringe pattern shifts by a certain distance on the screen when mica sheet of refractive index 1.6 and thickness 1.964 microns is introduced in the path of one of the interfering waves. The mica sheet is now removed and the distance between the slits and the screen is doubled. Means when the sheet is removed, they have doubled the distance of screen. It is found that the distance between successive maxima now is same as observed by the fringe width upon the introduction of mica sheet. You just need to calculate the wavelength of monochromatic light that is being used in this experiment. So lambda is to be determined. I would be writing like the data, like given is mu for particular material, that is mica is 1.6, thickness is given directly, that 1.964 micrometer, which could be converted to meters by multiplying 10 to the power minus 6. And after that, the new screen distance is doubled, that is d2 is going to be twice of d1. What is to be found out? Lambda, right? Just lambda is to be found out. And what is the formula? The formula is x naught equals to d by d mu minus 1 times of t. Also, x is nothing but going to be lambda d by d. The concept is x naught is always equated to the x. So I would be beginning solution with this same criteria. According to the given condition, x naught would be equated to x. So the formula would be also equated. So I would be saying that d1 upon d mu minus 1 t is now equals to lambda d2 by d. D and small d would be getting cancelled. D2 would be substituted as twice of d1 here, and I would be substituting all the values which are known. The only unknown in this particular sum right now is lambda. So we would be getting value of lambda here. On substituting, d2 was 2d1 and d1 would be getting cancelled. Small d would be getting cancelled. We would be just left with mu1 minus 1 t is equal to 2 lambda. Now students, mu is given, t is given, you just need to find out lambda. So lambda would be equal to mu minus 1 times of t upon 2. So I am just having values of mu as 1.6 minus 1, and lambda would be found out by substituting t. So it would be like 1.6 minus 1 into 1.964 into 10 raised to minus 6 the whole upon 2. So students, lambda would be nothing but equals to something simplified as 0.5892 into 10 raised to minus 6 meters. So this is going to be the answer to what is lambda. The lambda is 0.5892 into 10 raised to minus 6 meters. So student, this was the concept of shift, and that's it from this particular module. Thank you.